column is representing that property tax rate? TR.
Yes, TR, yes.
Good. Now, when you look at that variables there, are they numerical or they are categorical?
Numerical.
Thank you. Now, which variables are categorical?
The NP.
The type.
Type is
Location.
categorical. And
Location.
How many property tax types do we have?
2.
Thank you. Which other variable is categorical?
Location.
How many types?
2.
Which other categorical variable?
Assembly.
How many types?
District, municipal. 3.
3. Very good. So this is a typical example of a data type that we are talking about. Now, follow me here. Follow me. Nobody should get lost. You were told that the consultant believes that these tax rates, which you see on the first column, they depend on several factors like the number of people in a household. Now, which column do you think representing the number of people in the household?
Column B.
NP.
NP, column B, good. Now, it also depends on the value of the property represented by
V.
The number of housing units per square mile represented by
HE.
Average real income of inhabitants represented by
Y.
Monthly rent on the property represented by
RE.
the type of property represented by
Type.
location of the property represented by
Location.
Okay. By the way, for your information, the location is 3.
It's 3, yes.
I think one of you mentioned that it was 2. It's 3. You have
It's
urban.
3. Rural, urban, and suburban.
Good. And then finally, the assembly type is represented by
3. Municipal, metropolitan, and districts.
Assembly.
Please note something. You have a job to do as a group of about 11 people. This is your job. This will form a critical aspect of your continuous assessment. It will form 50% of your continuous assessment. That is why I want to take my time and explain things in total for you. And that is also why when you don't understand something, you tell me in total. I'm taking you back to the preamble so that we do some few things. So first thing the preamble is telling you is this. I'm taking you back. The moment the question showed, let me know.
It's showing.
Okay. Now, when you look at the preamble, the first question says, which is the dependent variable? And which variables are the independent variable? Is that not an easy question?
Yes.
Can't we even answer that one right here? Who can tell me the answer? What was the dependent variable? And what was the independent variable?
Sir, please go up a little.
I should go up, okay.
The dependent variable is property tax rate.
Property tax rates. Property tax rates.
And I'm sure you can identify which are the independent.
Yeah.
Yes.
Now look at the next question.
Yes, yes. The number of people in that and then all those things.
The question B says, for each variable, identify whether the variable is numerical or categorical, and then tell us the scale of measurement. You get a picture now?
Yeah.
Yeah.
So you should be able to go through each variable, that Excel column by column by column by column by column by column by column. And then you are able to tell us every single one of them. Opelinum. Are you with me so far, please?
Yes, please.
Prof, please come again.
Sorry? I didn't hear you. What did she say?
Prof, please come again.
Okay, which one? The A or the B?
The A.
No, you can't say the A because you have finished the A.
The
The moment you say A, it means that you weren't here. I asked you that question in order to determine whether you were here when I was talking. If you said A, it means you just joined us, true or false?
Okay. Please, sorry, I was driving. That was why.
If you are driving, it's not my fault, my dear. We are supposed to be online. And so if you are driving and you ask me a question about it, you ask me a question about the A, what it means is that you want me to go back all through. So we ask questions based on the one I have finished, not everything. Okay, so let's go to the C part. The C part says, run descriptive statistics of the data. Now, last time, Isa went through with you, and everything you're going to do, you're going to use R. Okay. Do you remember how he was able to run the descriptive statistics for the Burkutu venture data?
Sir, please, he didn't teach us how to use the R. He said when we meet this week.
Okay. So what I'm going to do now is this. I'm going to show you a little bit of it. Okay. But I will not use the data you guys are seeing right now. What I'm rather going to do is I'm going to use a different data. But at least he showed you the Burkutu venture data, right?
No.
So the question he answered with you, he didn't do any practical work with you.
Sir, we did the Burkutu venture, but he didn't use the R. He used the formulas.
He showed you the Burkutu venture data. He spoke about it. He asked questions.
Okay.
We interpreted an output of the regression, if I remember.
Okay, what kind of regression was that?
It was multiple regression, I think.
Yeah, what was the data? What was the name of the data? You have forgotten.
Yeah, I can't remember.
Okay, no problem. Let me show you. On your screen there is the Burkutu venture data.
Yeah, this is the data. These variables were there.
Oh, clearly. So you just said that you didn't even talk about it. Okay. So this is the data set. Now, this data set has a certain number of dependent variables. Of course, you always know that a dependent variable is one. And then dependent variables are normally many. Now, which variable here do you think is a dependent? I'm just recapping something he has done. Which variable do you think is a dependent variable here?
It was the Q.
Thank you. And the Q dependent on the price of the gym bitters, which is a P. The complement price of gym bitters, which was the C. The income of the people, which was the M. The location of the shop, which was LOC. The occupation of the people, which was OCC. And the religion of the people. Okay. So I'm going to ask you some questions. On looking at this, which variables are categorical and which ones are numerical? Just looking at this Burkutu data.
The categorical.
Religion is categorical.
Occupation is categorical. Location is categorical. And the QPC and M are all numerical.
Okay. So which ones are numerical independent variables?
There are P, C, M.
C and M.
ECM.
So you can now get a picture.
ECM.
It's the same knowledge that you will transfer to the property tax data in your assignment. Okay, now this data, we can take the data from here into R and work on it. So that's what I'm about to do so that you work me. I'm going to do the descriptive statistics of the data. You remember in the property tax data, you are asked to generate the descriptive statistics and you said R was not used. So I'm going to use the R and then you watch me do that. By the way, there's a video on how to download the R and then the R Studio on my channel, my YouTube channel. Oh, who has seen it? Who has seen that video?
I have downloaded it, but I haven't really watched.
That's okay. At least a good thing is that you downloaded it, so you know it's there. So when you go and watch it, you see everything about this Brukutu Jim Bitters. Everything, every question, every answer, and how R did all of it. Okay. In fact, I posted it in the group page. But what I think is that on that day, at that time, many of you were not yet, ready to to see what's happening. So please, ladies and gentlemen, I beg you, go there, go find it. Go there, go find it. Okay. Once one of your colleagues says he's got it, the rest of you should go there and go get it. It will help you big time. And I mean, real big time. It will help you. So please go there and go download that thing. Now, I just want to see if I can show you, the video that you need to be able to, let me see where I can get it. Download. R Studio. Okay, but it's there. Go and get the video, I beg. I'm trying to see if I can catch it easily for you. But because I'm a bit in a hurry, I've not been able to get it. Let me see. Okay, let me see what I can put this. Very, very simple.
Good grammar and spelling are important, but if you want to write,
I'm trying to see if I can put that video on your page for you. But yes, yeah. This is a video. So I'm just putting the video now in your WhatsApp group page. Please go and watch the video. But it will not prevent me from still, and watch the video prior to that. It will not prevent me from still giving you an idea of how it works. So we are going to take this data set, which is this Brukutu data set, into R. You Control A to highlight. Then you do Control C to copy it. Then you go to your R Studio. So I'm going to my R Studio. Now, how do you download the R Studio? Well, like I said, I can easily show you. So, yeah, but that's the one I've given you the video. But just for the purposes of, easiness, guys, what I want to do is to just give you a bit of an idea. So go to R here, go to Google and type the letter R. Okay, just type the letter R. Please, I hope you can see my screen there. Can you see my screen?
Yes, Doc.
So the first thing that comes is the R project for statistical computing. Click it, go to the top, which is download. Download R. Then go through the list, scroll through the list and look for Bristol University, UK. So go down to UK, it is in alphabetical order, and choose the one for the UK, the first one, University of Bristol. I hope you see what I see. And then click on that link for the University of Bristol. And then choose download for Windows. You have to download for other ones, but choose download for Windows. And then click on the install R for the first time. You will see the latest version at the top. And click the download R 4 point, whichever latest version that you have. Save it onto your computer desktop or anywhere. And then once you have saved it, all you got to do is to install it. After installing, that's it, you are done. You will not need to open it, but I'm sure you how to open something else that will automatically open this R. Please, you follow there. Can I proceed? Talk to me.
Go over it again.
Can you please go over it again?
Doc, please go over it again.
Okay, so the first thing you do is that you type R in Google, the letter R. It will take you to the first page, which is the R project for statistical computing. You click on that. It will take you to the next page, and at the top, you see getting started. In the second line, you will see to download R. Click on the download R. Once you click on that, a pop-up will come, which will give you a lot of universities and a lot of companies that are actually having the R. Scroll down to the UK. It is in country alphabetical order. Choose UK, the first one, the University of Bristol. There is a URL. Click on that. A pop-up will come, and it will show you the 3 options of downloading for Linux, downloading for Mac, downloading for Windows. And then you can choose whichever one your computer does with. I normally advise that you go for the downloading for Windows. When you click on that, it will take you to the next page, which is R for Windows. You will see there, at that R for Windows, you see the something known as install for the first time. Install for the first time. So you click on the install for the first time, and then what will happen? You can now install R. It will take you to the next page where you will now download the R version 4 point something. Okay. When you click that download, the setup will be saved onto your desktop. It will ask you where do you want it to be saved. Then you can save it on your desktop. During the installation process, you will have the choice of choosing the 32-bit Windows. And that one is at the top here, or the 64-bit. You should know which bit your computer is dealing with. And if you want to choose the 32-bit, you don't have to bother yourself with a 64-bit. So there are 2 of them you have to tick. Automatically, both of them has been ticked, but you have to know which one you want and select that one and untick the other. And then install it onto your computer. That's it. Once you've installed it onto your computer, it is there in the memory of the computer. I think it's clear now, isn't it?
Yes.
The next thing to do is to type in the Google R Studio. Follow me. Follow me. If you write it, you might not be able. R Studio, just the letter R Studio. And that one too will take you to the first website. You see the website is download the R Studio IDE. Download the R Studio RDE. So you click that. It will take you to a new page, and that new page is where you will do the download. You have to choose your version. Please note all of these things are free. All of them are free. Scroll down, and you see there are 4 types of the R Studio. You want the first one, R Studio Desktop. That's the one you're looking for. Okay. You're looking for the R Studio Desktop, that one, R Studio Desktop. That is the one you're looking for. And your goal is to download that. It's free. It's free. So how do you download that? Well, it's very simple. Scroll down, and you see free download. Click on download. Once you click on download, it will go to a new page, and you can see that it will be warning you, and it will tell you that, hey, hang on. Step 1, remember to install the R first. Remember to install R first. So that is why we downloaded the R first and then install the R on the computer. Then step 2, it will tell you now if you have downloaded the R first. Then step 2 is to download the R Studio for your desktop. And the correct R Studio is there. You can see that mine, the one recommended for my computer is the version, what do you call it? It's a version 64-bit. Okay, that's the one you can see for mine. So you have the 64-bit there for Windows 10. So you just click the one on the top. Once you click it, a pop-up will come. And you can see that in my own, the pop-up has shown. As the pop-up comes, save it onto your computer. Give it some time. Within some few seconds, it will be done. And then, this is where it's interesting. Go to your computer and install the R Studio. And also install the R Studio. In the process of installing the R Studio, it will recognize the R and will guide you nicely so that you can merge the two. Once the R Studio has been installed, ladies and gentlemen, when you go onto your desktop, you will see something called the letter R, an icon called R. It is the R you will open. It is not the R, sorry, it is the R Studio you will open. You see something called R. In fact, if you can't see the R, anytime go to your computer Windows search and type R Studio. The moment you start typing R Studio, a pop-up will show at the top, and it will give you the name, an application, R Studio. That means that you have installed. You will never have to open the R. You rather have to open the R Studio. You will never have to open the R. You rather have to open the R Studio. That's it. And then once you open it, you will get a plain site. I have opened mine. Mine looks manya. So what I'm going to do is I'm going to open a new page, which you can see. Let me open mine and show you. That is mine. You can see that the cursor is blinking at what number? What number?
1.
Good. So now, what you are now going to do, the first thing you're going to do is to load the data. And please don't try to fully understand what I'm going to do. You have to go and watch it again. Okay, loading the data, you type read dot. You give a name of the data. Let's call it gin. Okay, we are calling it gin because it's gin bitters. And then write equal to. That's the name of the data. And I use a command called read dot delame into bracket. Okay, double apostrophe, clipboard. That's it. You use this command. Anytime you bring a hash sign, it means that you want to write some instructions. So I can write an instruction since I brought a hash sign. The instruction is that the name gin is the name we are calling, or the name we call our data in R. Okay. This command exports the data from Excel to R. So this is just an instruction. The moment I click enter, the cursor goes to number 2. Okay, you can save it into your My Document. You can save it into your My Document. Okay. So this command will actually bring the data set. Do you remember the data set in Excel? Okay. Let me take you back to the Excel. This was the data set in Excel. Kill, PCM, location, occupation, religion. So you bring this data set from Excel. How do you do it? Control A to highlight. Control 8 to highlight the whole data. Control C to copy. Okay. When you copy, you now move to the R where you did your typing. Okay. Where I'm typing is known as the command window. Command window. And when I want to see the results, I go to the space down there. It is called the console. The console. You see it written there. So now that I've copied the data, I just have to click on the name I called it in the R. And the name was what? The name was Jim. Just click anywhere there. Do you see my cursor is blinking at Jim?
Yes.
Okay. Once the cursor is there, just look at the top. You see run at the top. You see run. If you don't see, I'm trying to point it there for you. Do you now see run? Oh, you don't see. If you don't see, I see. This is it. Do you see run?
Yeah.
Yes, please.
So that is what you command. Another way of using that run is by just typing what do you call it? You just type command control enter. If I want to put the cursor there at run, the control enter will show. The control enter will show even before clicking, telling you that it is going to run the command. So I'm going to click run, okay? And when you click run, in this case, it says that there's a mistake. And let me tell you why there's a mistake. Because the letter was supposed to be read, but I made it what? Right. R always punishes you. So you have to make it right. Guys, what it means is that when you are doing your tax data, you have to check it. It's supposed to be read and not write. Okay. The other thing you should note also, the other thing you should note is that I called my name of the data Jim, but you can choose to call your tax property returns data anything. You can even call it tax and then make it tax equal to read.delin. Are you with me? It's very important. It's just following my sequence of what I'm doing and do the same thing. So now that I've corrected the thing, let me run it again. And you see that there is no error at the bottom. You can see that everything has been nicely written in blue, which means that there is no error at all. Everything is that. It means that the data is loaded. That's what it means. But guys, how do you know that it's loaded? One way you can know that it's loaded is go and highlight the name you gave it in R. It's called Jim. And click and run that. Look down there. When you run that, you can see down there that the entire data now is showing down there in the console. You guys see it? Do you guys see it?
Yes, sir.
Very good. So this means that your data has been loaded into the memory of R. Okay. Now we go to command number 2. Go click there and let's work on command number 2. Now, just like the just like the property tax rate. If you can remember, one of the questions says run the descriptive statistics of the data. Do you remember? You remember?
Yes.
Okay. So guys, follow me. What I'm going to do is that I'm going to run the descriptive statistics of this book to Jim Peters data. Okay. I'm just doing it for this book to Jim Peters data. So we also suggest follow me. Now, let's go to command number 2. Can we please have some bit of silence? Okay. It is a way of showing decorum and a bit of respect to the rest of the people on the call. Okay. So what you do now is we want to show descriptive statistics. Descriptive statistics is the same as summary statistics. You cannot do that. You cannot do that unless you have installed a package. The name of the package is called psych. So you need to type a command called require psych. Require into brackets psych. Okay. Require into brackets psych. Is this psych or E? Okay, so before you can actually command this command, you need to go and install it. So on the bottom right, look on the bottom right, you will see something called packages in one of the tabs. Okay. In one of the tabs, you see something known as packages. Package. I'm just going to show you packages. So this is it. Packages is here. Packages. So click on packages and choose install. Click on packages and choose install. Okay, that's what we're going to do then. Packages and then install. Packages and then install. Now, when you do packages and then you do install, what's going to happen is that you are going to be given a pop-up. It is a package parameter dialog box. You see, it has popped up. And in there, you type the name of the package you want. The name of the package is psych, P-S-Y, there's no E. And you see that it will come, it will show by itself, P-S-Y-C-H. You click on that and click install. Your internet must be running. This is done only once, ever. Then you click install. I have already installed it. Okay, so I don't have to install it again. How do I know I've already installed it? Look under packages. You see some search button there. If I try to click this search button here and type PSY, the psych will show. So that means that I've already installed it. All right. So you run that command psych. Okay. How do you run it? After you type it in number 2, click at the top run or click Control Enter. And that's it. It has loaded nicely. Now you are ready to run the descriptive statistics. The descriptive statistics is written as describe. So you type it, describe into brackets, the name of the data set. And what is the name of the data set? Look at the top, command number 1, we called it GIN. So you just write describe GIN. Okay. So it is going to show you the results. Let's run it, Control Enter or click Run while the cursor is blinking in number 3. Okay. It says that describe GIN could not find describe. Okay. So that means that something is not done. Okay, it's because I'm using a new listing. So I need to install the site. Okay, so I typed require site. I should have typed library site. Okay. Library. Oh, I use capital letters. I think the key point is I should have used small letters. That's the most important thing. Okay. So now let's go and run the describe. Watch it. And you see the results down there. Guys, do you see the results down there in the console for the descriptive statistics?
Yes.
All right. Follow me. It will help you. Follow me. It will help you. So now let me take you back to the property tax rates question. Because what we are doing is for gym bitters. The property tax rate question. The question C, what did it say? The question C, what did it say?
Descriptive statistics of
Run descriptive statistics for the data.
That is what we just did for our Brukutu data. So when you also have your own, that is what you will do. Okay, once you've done that, there are some questions which you answer here. What is the standard deviation of NP? Skewness of Y variable? Ketosis of RE? Mean of TR? So I can now take you back to my own. I'm going to ask you a similar question for this one. Who can tell me the median for M? Who can tell me the median for M, looking at the results? So these results, you have to cut and paste them into your document. Then answer the questions.
18.25.
18.25, very good. Who can tell me the skewness for P? Skewness for P.
Negative 0.1.
2.14.
Good. Who can tell me the mean for Q? The mean for Q.
175.
175. 00.
The maximum absolute deviation for location. The maximum absolute deviation for location.
2.0.
What?
2.0.
Wrong. The maximum absolute deviation for location.
Deviation.
It's not 1.5.
Deviation.
0.51.
The maximum
0.51.
is wrong. What is the maximum absolute deviation?
Deviation is standard deviation. Maximum.
49.46.
That's wrong. What is the maximum absolute deviation? for location?
0.74.
0.74 is the right thing. You see, when you don't know and you search through the mind, the cerebellum and the cerebrum of your mind, you look for the archives of anything you've ever found. You don't get it. You search. Your brain is wired in such a way that it searches the entire coconut of the head. There is no stored information that the brain is able to catch. It combs and combs and combs. It finds no files. No files is in the folder of the brain. And that is why people were just giving answers left, right, and center. It's not because of anything. You were guessing. Because you didn't know that the minimum absolute deviation is the same as the MAD in the data set.
MAD.
So whatever thing that comes into your archives is not correct, but you confidently and assuredly mentions it. So that if it actually fits, then you convince yourself that you are good. When in reality, it was a lottery ticket used. It's a files. The files are not there in the brain. Before you can be able to produce the files, you must have first of all put in the files. There is no output without an input. Okay, so that is it. So you should be able to generate the descriptive statistics and then be able to solve questions related to that. Now let me take you back to the question, and then I will apply the same thing to this one. Question E, who can read that question?
Explain each of the statistics identified in DO.
To a layman who has no knowledge.
Explain each of the statistics identified in D to a layman who has no knowledge in statistics.
Good. So when you go and pick them and you are explaining the mean of this, you should be able to explain the simple exercise to a layman. That one I'll leave you to go and take. In a simple, some of you were talking about standard deviation. What do you mean to a very simple level? What do you mean? Now, question F, read it.
Run a descriptive statistics for the data based on the assembly. Which group has the highest property tax rate?
Okay, So this is a situation where you are able to do the descriptive statistics according to groups. According to groups. Now let me show you in our own the groups that we have in the Brukutu data set. How many groups do we have? How many levels, group levels do we have? How many groups? We have location, we have occupation, we have religion. Location has 2 levels. Occupation has 3 levels. Religion has 3 levels. What do I mean by 3 levels? Because when you look at religion, there are 3 of the religions that are in there: Muslim, Buddhist, Christians. So that's what I mean by the levels. So when you look at this thing, okay, I can ask you the same question that run the descriptive statistics according to occupation. Okay, run the descriptive statistics according to occupation. How do you go about that? I want to do it for occupation so that you will understand. I could have used for location, I could have used any other thing. It's a very simple thing. Okay, it's a very simple thing. There are 2 ways you can handle that. There are 2 ways you can handle the descriptive statistics according to what do you call it? According to religion. So what I'm going to do now is I'm going to show you how you can do the descriptive statistics according to religion. Okay. So let me take you back to the R. So guys, look at the R number 4. Okay. This is the way you write it according to. So the first one, number 3, is telling you about summary, of the whole data set. I'm just giving you the instruction. Summary of the whole data set. Okay. But this one, you have to write describe. Okay. And you can choose this describe with a by, describe by, with a by being capital. And I write the name of the data. The name of the data is gen. And then you write religion. Our religion is inside the gen. So you write gen $ religion. Okay. So that's all you do. What am I doing? What I want to do is that I want him to give me the same descriptive statistics, the mean, the median, the standard deviation, the minimum, the maximum. I want you to give me the same thing, but according to the groups. Which group? Religion. So I want you to give me the mean for Christian, the mean of their maybe price, the mean of their maybe income. I want you to also do the same thing for Buddhists, for Muslims, for Christians. So that's a description by group. So let's run this command number 4 and look down there in the console. Let me scroll up a bit so that I can see. So you can see that when I did that, the groups have been shown. You can see that at the bottom, you have descriptive statistics by this particular group. The group is Buddhist. And you can see that for the group of Buddhists, you have their average mean, you have their standard deviation, you have their median, you have their trim mean, you have their minimum absolute deviation, you have their minimum, you have their maximum, their range, their skewness, their kurtosis, and the standard errors. For only Buddhists, as far as each variable is concerned. Then you also have the same thing for Christians, as far as each variable is concerned. And finally, you have the same thing for Muslims. So you can see that Muslims, the number of N, the sample size for Muslims are 16. 16 for each variable. And when you go to Christians, the total number of sample in Christians are how many?
12.
And what about Buddhists?
The screen.
12. It's still 12.
If I ask you the question that I want you to tell me the minimum value, okay, the minimum value of price among the Christians, what would that be? the minimum value of price among the Christians, what would that be? Look in the chat there.
12.0. 12.0.
Is the right answer. So what you do is that this is a minimum value. By the way, this is Christians. The minimum value among the Christians, this is a minimum value. I'm looking for the price. So if you look at this column, this row, the price is at 12. Price is at 12. So this is how you are able to describe according to group. I could have done the same thing. Let me go down up there. I could have done the same thing. Let me bring this down. I could have done the same thing and describe according to location. So I'll just type Jane, comma, okay, and then I'll do Jane dollar lock. So this means that it's going to now give me the descriptive statistics according to rural and urban. When you click run, you see the results down there. Look at the results down there. You see rural at the top, then you see urban at the down. So that is how you do descriptive statistics. And then you can answer any question related to that. Any question? You will do these all. So it's very important to do. Now the next question, which is G, who can read the question for G? Like I said, I'm not using your own.
Using the histogram, density plots, and Shapiro works test Shapiro works tests of normality. Test if property tax rate is normally distributed.
Good. So this is a very important, this one carries about 20 marks, okay? You're going to do graphs. You're going to do histogram, but there was a particular variable, okay? Test if the property tax rate is normal. I want us to use the variable called kill in our own. So I'm going to ask the question here, okay? And I'm going to use hash sign to indicate the question. Test if the quantity demanded of gene, which is kill, is normally distributed. That's it. Okay. So that's what we are going to do. And according to the rule, we are supposed to use what? Histogram. Histogram. Now, histogram is simple. Just write hist. Once you type histogram, hist, it comes. Then you now do the name of the data first, gene, then you bring the dollar, and then the variable you want to check whether it's normally distributed. And we are testing for kill. I just bring kill there. And then you run this result. It's going to produce a nice graph on the bottom right of your screen. Okay, so once I click run, you check the bottom right of the screen. You can see that it has generated a beautiful graph, histogram. Now that graph is looking great. I can add a color, so you can do comma, okay, and then do color, C-O-L, and then you make it equal to, then you type the name of the color. Let's call it red. You see, I put a red in double apostrophe. Let's run it again. And you can now see that the color is now showing red. You can change the color, whichever color you want, primary colors in particular. Choose blue, the color becomes blue. You can change the blue and choose yellow, and then the color becomes yellow. You can change the color and choose green, color becomes green. So you can do any of these colors and run the results, and you can see any of the results. So this is showing us a histogram of the gene, the quantity demanded kill. And we are to determine whether it is normally distributed. Guys, do you know when we say something is normally distributed? Let me show you. Now, for those of you who have done management science, project management, this is an easy thing. Okay. We say that something is normally distributed if it looks like something like this. Okay. If I draw something and then it looks like that bell-shaped curve. You remember the bell-shaped curve? Okay. Remember that bell-shaped curve? Exactly.
Yeah. Yes, yeah, that's it.
That's where you see that the histogram, all of them are inside the bell-shaped curve, and the tallest one is in the middle. But when you look at what I've just done and the histogram I've drawn, it doesn't look like it is a bell-shaped curve. According to the rule, we should use another graph. What is that graph? Well, he said that we should use a kernel density graph. Okay. Kernel density. So it's just a matter of typing the word density. Let me type density. You see, it's there, density. Then you type the same thing you type there, gen. Okay. And then you bring the dollar symbol and then the kill. You want to check whether kill is normally distributed. That thing I was drawing, that's what we are trying to do now. Oh, what did I do? Okay. The density. Let me be sure. Okay, the density. Oh, okay. So you just do plot into brackets. Plot into brackets before you do the density. This is a command. That's it. If you want a color, you can just again add a color. Okay. You can add a color and then choose any color that you want to choose. Let's call it like blue. And you can see that now it's showing the blue density graph. Guys, when you look at this, does this show like it's normally distributed? You can tell me.
No.
It doesn't. Okay.
No, no.
In fact, it looks like this one has 2 peaks.
Yes.
But a normal distribution should have how many peaks?
1.
1. This one is having only 2, so clearly it's not normally
1.
So the 2 graphs are clearly showing that the thing is not normally distributed. So what do we do? Well, according to the rule, you should go and do a test. Let me just go back to the question and remind you of what your question was, for example, asking in your case. It says use a test, and the name of the test is called Shapiro-Wilks test. Somebody would think I'm speaking Hebrew. I'm not speaking Hebrew. Okay. It's just Shapiro-Wilks test. That's the name, nothing else. Okay. So let's try and then do that Shapiro-Wilks test. It's a very simple command that you use. So I'm going to enter, go to command number 9, and then I'll type Shapiro. The moment you start typing, it will show Shapiro.test. Then you put into bracket gen. In this case, the variable I'm dealing with is kill. So I'll do gen $kill. You just run it. Look down there. The answer is going to show down there in the console. And there you go. The console is giving us the result. The result is Shapiro-Wilks normality test. The name of the data we used was kill. The test statistic, and this is important. You guys remember some test statistics that we did. The test statistic, okay, that we are using here. Like we used to have a test statistic called T. Do you remember? We used to have T-test. We also used to have Mann-Whitney U-test. Do you remember?
Yes.
Now this test here is called what? If you look down there, what's the name? What letter?
Shapiro-Wilks test. P-value.
W.
P-value.
W.
It's
Is it
W.
W or P-value?
The test is W test. So that is a test. Now, so the test statistic is 0.91. Now, for you to reject the null or the not the null, this is the point. Listen carefully. The null always say that the data is normal. That's what the null is saying. The data is normal. Now, whenever the p-value is greater than 5%, Whenever the p-value is greater than 5%, and I mean this is very important, because normally we know that when the when the p-value is less than 5%, that's when you reject the null hypothesis. Okay. We normally reject the null hypothesis when the p-value is less than 5%. But here, please note that the data, the null hypothesis says that the data is not normal. Okay. That's what the null hypothesis is saying. The data is not normal. The alternative is saying that the data is normal. And here is a rule. The rule is that whenever the p-value is greater than 5%, you reject the null. Sorry, the null is saying that the data is normal. I don't know why. I'll keep changing. The null is saying that the data is normal. The data is normal. And then the alternative is saying that the data is not normal. Okay. And the rule is this: when the p-value is less than 5%, you reject. When the p-value is greater than 5%, you reject the null hypothesis. Okay. When the p-value is greater, you put that down, write it down. You see, if you are not used to writing things down, it means that you are not used to learning. Learning, the best way of learning is putting things down. So when the p-value is greater than 5%, then we say that, in fact, we now reject the null hypothesis when the p-value is greater than 5%. We reject the null hypothesis when the p-value is greater than 5%. We reject the null hypothesis when the p-value is greater than 5%. We reject the null hypothesis. So in this case, are we rejecting the null hypothesis of normality, or we are not?
We are not.
We are not. Okay. We are not. Oh. If the p-value is greater than 5%, we reject the null hypothesis. Okay. So I made a mistake again. So the thing is that the null hypothesis says that the data is non-normal. I don't know why I keep messing this up. So please let me just beautifully correct this before we move on. I keep writing and then changing it. So the null is that the data is non-normal. That's a null. Okay, the data is non-normal. The alternative is saying that it's normal. I don't know why I keep altering it. But please forgive me, I'm sorry. Because I know that some of you are already in a wonderland, and now I keep changing it again for you. Then it means you're in double wonderland. The null is that the data is not normal. The alternative is that the data is normal.
Now, please, how did we formulate the hypothesis?
How did you formulate the hypothesis?
Yes.
We don't need a sentence to formulate. These hypotheses are already formulated in life. Okay. The hypothesis is already formulated that the kernel density estimation that you see here, okay, this kernel density estimation, it has to be, well, we want it to be normally distributed. And the null is saying that the original hypothesis is that it's not normal. And then the alternative is saying that it is normal. So when you reject the null hypothesis, what you are saying is that the data is normally distributed. When you reject the null hypothesis, and the only thing that will make you reject the null hypothesis is when the p-value is greater than 5%. In our case, look at the p-value here. The p-value is not greater than 5%. Okay. So we cannot reject the null hypothesis in this case, which means that we are concluding that the data is not normal. And that's why the p-value is like that. This goes against the usual p-values that we normally know. Normally, when the p-value is less than 5%, that's when we say that we reject the null. But here, for normality alone, when the value is greater than 5%, that is when we reject the null. Because in this case, the value is not greater than 5%, we cannot reject the null. So we can conclude that this variable Q is not normally distributed. Now, how do we know that that's even true? That's true because when you check the kernel density we drew, and then when you check the histogram that we drew, you can clearly see that they were not normal. Do you remember? And the test is confirming that they are not normally distributed. So just get to that. You see the way it has slightly confused me. You want to be able to get to that. Okay. But of course, you might not be able to get that immediately. So you have to go through it again. Okay. So this is a test. Now let me take you back. Unless you have a question, you raise your hand and let me know. Other than that, I'm going to take you back to your tax returns questions. Any question before? Now go to H. Somebody should read the question H. And then I will apply it to our book together.
H.
Create a scatter plot matrix of TR. Francis, you read.
Continue.
Look at Africans. Okay.
Okay, H. Create a scatter plot matrix of TR, comma, VIN, comma, NP, comma, Y, and RE. From the matrix, what is the relationship between tax rate and monthly rent?
All right, so Gift, you'll be doing all the reading, okay? So just so that you know, so that there are no interruptions on that. And then Francis, you answer me all the questions. Since the rest are watching us, you know, here. Some are enjoying watching the TV. They can watch that now. Okay, so create a scatter plot matrix of some variables. These are selected variables. And for most of the time, these selected variables are, what do you call it? They are variables that you will be given. Okay, just like the one that, you know, what do you call it? The one that you have been given, you know, in that regard. Okay, so this is what we're going to do. We're going to do that scatter plot matrix. By the way, the scatter plot matrix, to be honest, is done, is important. For you to be able to do that scatter plot matrix, there is something you have to do. There's something we have to do first. Okay. So I'm just going to show you how you can go ahead . How you can go ahead and do these scatter plot matrix. I just want to be sure that everything is in order, and then we can do this scatter plot matrix, because sometimes, okay. So I'm going to do some selected variables. Okay, I'm going to do some selected variables. So let me take you to R. Okay. I'm going to do some selected variables in command number 10. I'm going to generate a scatter plot matrix of the following variables. We type the number pairs. Okay, pairs. And that is going to be, and I'm going to pick some of the variables. And the variables I'm picking, pairs, then you bring the symbol called a tilde sign. Then I'm writing Q, which is one of the variables, it's numerical. I'm writing P, which is another variable, it's numerical. I'm writing C, which is another variable, numerical. I'm writing M, which is another variable, numerical. I want to change the color to blue. Okay, let me make it red. And I'm picking everything from the data set called Gen. So this is a scatter plot method. But before you can do that, put some command at the top. The command you have to put at the top is called H miscellaneous. Okay, this command, H miscellaneous, it's a one-time command that you have to. Okay, so you type library, library into brackets, H miscellaneous. Now, this is a package that you have to install one time. Okay, it's a package. How do you install the package? I've shown you. Go to packages on the right. Okay, and then click install, and then you type H miscellaneous. Okay. And once you start typing, it will pop. It will pop. It will pop up. And then you click H miscellaneous and click install, and then install it. I have already installed it. So all you have to do is to run the library miscellaneous. Okay. Once you do that, look down there. It shows that it has been loaded. And then run this command pairs. This is called scatter plot matrix. Let me put the instruction there. This is the scatter plot matrix. I'm going to show you why it's called a scatter plot matrix. So you are doing a kind of a correlation matrix, but you are scatter plotting them in a graph. Click run and look on the right. You see that it is showing a graphical illustration of the relationship. You guys might remember correlation, of the correlation between some of the variables and other variables. Okay. So how do you now, somebody says, what to, I will advise you to use Windows. Yes, use Windows, I beg you. Okay. Use Windows is the best in this context. Okay. Mac OS is fine, but sometimes gives you some complications. And I can't handle those complications for you now. Okay. So use Windows. All right. So how do you read this scatter plot? It's very simple. Very simple. All you do is this. You go here. You read it by looking on the vertical and the horizontal. Okay. So let's say I want to look at the scatter plot matrix between Q and C. It will be Q moving down here and C moving leftward, where they will meet. That area here, that is where the scatter plot matrix is. Okay. This section here, that is where the scatter plot matrix. And when you look at the data there, you can see that they look like they are positively related. It looks like they are positively related. So that is how you do the scatter plot matrix. Now, go back to your information that I was giving you. Okay, you remember that question we're looking at? After you've done your scatter plot matrix, then he asks you questions like, from the matrix, what is the relationship between something and something? Okay, that question simply is asking you whether it is positive or negative or neutral. That's all it's doing. Finish. That's it. Let's go to question I. Read the question I.
Run a Pearson correlation in out to 2 decimal places with p-values for the entire data set, including dummy variables in brackets, to show the relationship among the variables.
So this question is an important question. Run a Pearson correlation. And then he's asking you that in this case, okay, you should do it related to 2 decimal places with p-values for the entire data set, including dummy variables. Okay, including dummy variables. Now, when you are doing this, including dummy variables, it's a little bit quirky. So I'm going to just do excluding. I'm going to do excluding dummy variables so that you don't die. Okay. You can do including, but then at a level, I'll just do excluding for now. Okay, so what it means is that There are two ways you can do this, to be honest. Okay. One way you can do this is you will do something called, and again, what you are doing is that you are generating correlation matrix with p-values. But in this case, you're supposed to include the p-values. Now, when you are including the p-value, sometimes it can be a little bit. Okay. So I'm just going to show you how you can just do, the data you had, you would have noticed that you're supposed to sometimes have, look down there. You're supposed to have, you can convert this data set into what do you call it? Into numerical variables, where the dummy variables have been coded. Okay. And again, watch the videos I have. You'll see how you can code them into, how you can convert the dummy variables, which are actual English, like urban, rural. You can make it 1, 0, 1, 0, 1, 0, 0, 0, 1, 1, 1, 1, 1, 0, 1. You can code them. And when you do that, the meaning will still be there, but they will all be numbers now, which will make it easier. But this command is rounding the correlation matrix. This time is for the entire data set. But if you don't want to include the dummy variables, okay, if you don't want to include the dummy variables, you can remove them. And there's a command you can use to remove the dummy variables. Okay, I'm going to show you this command. It's a bit tricky. It's a bit tricky, and I'm going to just show you. So after this gene, okay, you now say that minus which names in the data. So this command will help you to remove the dummy variables. Okay. So you can see that the dummy variables are location, occupation, religion. Okay. And the whole thing must be correct to 2 decimal places. Go and check this. Command number 12 is quite complex, but you have to just get it. Once you have that, once you have excluded the dummy variables, you can run this command. So in your case, you will have to identify the dummy variables, remove them, and then run this command. Even there's a mistake in there. So let me see. 1, 2, close bracket. One, two. I need to close this. Yeah, now it's working. At the bottom there, you see the correlation matrix there. Okay. So that is a correlation matrix with, okay, we correct to 2 decimal places. Okay, correlation matrix correct to 2 decimal places. However, it says that you should do the correlation matrix with p-values. Okay, so for me, that is the key and the most important thing. How do you generate the correlation matrix with p-values? Now, you're going to do this. You're going to do this command, which is library miscellaneous again. Okay, I'm just copying and pasting. Library miscellaneous again. And then you are going to now have a command known as rcore, okay, rcore into bracket as dot matrix. Rcore into bracket as dot matrix. And then whatever is in that matrix, you're going to put it there. And in my case, whatever you have there, I'm going to put this core gen, the same thing. correct to 2 decimal places. I think I've exceeded a bracket, but let me do it and see. Okay, let me just go backward so that you can see the big information I've just indicated. Okay, so look at it carefully. You have to just go and take your time and look at it. Okay, let's run that. And that's it, beautiful, it worked. Okay, now let me show you the results down there in the console. So down there in the console, this is a correlation matrix. The sample size is 40. And right below the 40, you have a correlation of the p-values. Okay, the correlation of the p-values. That's what you see there. What does that mean? What it means is that if you pick the first number here, let's take the first number, which is negative 0.87. It is a correlation between P and Q, or it is a correlation between Q and P. Okay. When you do that, what you now do is that each p-value will be the corresponding relationship between P and Q here. Okay, that's what you see. And you have OE plus 00, which simply means that it is 0. Okay, it means that it is 0.00. Okay, that's what it means. But when you have something like this, the 7E minus 04, what it means is that there are 4 zeros before the 7. Okay, so 7E minus 04, okay, the p-value there means that, okay, it means that there are 4 zeros, 0.000 before the 7. Okay. That is what the 7E minus 04, that's what it means. Okay, which in this case is also approximately 0. So this is how you generate the correlation matrix with p values using the R command. Very good. Again, if you are following me, you will get it. If you are not following me, you just have to go through the ones you don't fully understand, and then you can also get it. You know, sometimes it's just try your hands on some of them, and then ensuring that you did the best you could, and you were able to do it. That's all. All right. Let's go to the next question. And all of these are important. What? All of these are important for your assignment, but they're also important for your exams. Because your exams, I would not let you do the thing in R. For exams, I would do everything in R. And then I would rather pour the answers, the results, plenty tables and results to you. And your job is to answer some of these questions. You see, now the J question is asking you some questions. Read the question for J. Read the question.
Using your results, is the correlation between TR and MP significant?
Okay.
Justify.
So
I identify 3 potentially very good predictors.
Stop reading. Okay, let's try and answer them one by one. So the question is a correlation between something and something significant? Now I can take you to the results. Okay, and look at the correlation down here. I can ask you that is a correlation between P and C significant? By the way, what is the correlation coefficient between P and C? You see it, who can tell me? Between P and C.
Negative 0.74.
Excellent. Negative 0.74. The P and C, they meet at the junction here. Now, for you to know whether that value is significant, you check its corresponding P value down there. And whenever that P value is less than 5%, it means that the correlation is significant. So what is its corresponding P value? You just look at the P value section here and match P and C. And it is OE plus 00. Is that significant or is not significant? OE plus 00 means that it is 0.00. That's what it means. It's simply 0. And when the P value is 0, it means that the correlation is what? Significant. It means the correlation is significant. So it means that the value you mentioned here at the top, negative 0.74, that value is statistically significant. That's it. That is how you answer that question. Now, the other question that you were going to read, I didn't answer. It says, identify 3 potentially very good predictors. Isa has gone through that one with you. Which 3 pairs of variables are mostly multicollinear? I'm sure you went through that with you as well, didn't he? Did he? Exactly. Multicollinearity, highly correlated, no correlation, positive correlation, all of that. You got that. So I could ask several questions related to that based on the results. So this means that if you generated a wrong result from question I to B, you will not be able to answer a correct answer because your results are wrong. So that's why it's important to run the whole thing nicely to get the results better. Okay. Question K.
Run a simple regression of TR on RE and use it to create a red scatter plot of TR and RE with a blue fitted line. Name the graph my MBA special plot.
Okay, so this is a loaded run, hands on deck. You know what some people are going to do? They're going to say that they are tired of COVID-19, so they won't do it. Their friends should do it for them because they are pregnant. It happens. It happens. Sometimes some people use some lovely excuses to make their colleagues do the work for them. If you do that, you will be very, very unhappy in your exams. So please don't do that. And the exams is a hands-on practical work. I'm telling you, because there are some number of people on the call, and for some reason, okay, about 7 people have left the call for good. So it happens. Some people will take it very well. Others will take it too very well. The results will show. So run a simple regression of TR on RE. Okay. I want to ask a simple question in what we are doing now. To run a simple regression of Q on P and use it to create a red scatter plot. Okay. So I'm asking that question, but I'm going to do it in our own. One, you said, will you get another opportunity to go through using the R Rstudio? Okay. Please focus on what we are doing. I'm not interested in what the future is. I'm interested in what the present is now. So let's finish this. Ask questions related to this, then what opportunity we'll get later. Focus on what we are doing now. Very important. Focus. Focus. Go check the meaning of focus. Neglect everything on the side and cook it, but later on come back to the things you've neglected. That's the meaning of focus. So please focus. I understand the nature of your question. That's why I'm saying focus now. Okay, so we are going to create a simple regression, a very simple regression. And then we will add a fitted line to it and all of that. Okay, we're going to create a simple regression and add a fitted line. Okay, so how do we do that? Well, I'm going to give a name and then we will do that together. So first thing is we're going to do a scatter plot. So let me take you to the R. Okay. I'm going to type this in command number 15. 15. So let's call it plot into bracket. We are doing a simple regression of Q on P. So look at the way I'm using. There's a symbol I've written there, that tilde sign. Okay. That tilde sign, it helps you to be able to do that. Okay. So this is the same command I'm writing down, but this time I've just made it quickly. Okay. So if you look at it, it's plot Q is regressed on P. Okay. And the color should be blue. The line weight, the line weight is LWD, should be 2. You can make it like 4. That's just the thickness of the line, the regression line. The name of the data is still Jane. The title, you were told to call the title My MBA Special Plot. So that is the name we want to give to it. Okay. And then you bring a semicolon and add an outline. This outline is like the fitted line that you're drawing. And we want to give a name to the regression and call it Jane Simple. The line width for the outline is also there. The color is red. So this is it. The most important thing is that we are regressing the Q on the P. So I'm going to run this, and then you check the results here on the bottom right. So when I run it, check the results on the bottom right. There you go. My MBA's special plot. So you can see that we've been able to do a simple regression of Q on the y-axis, price on the x-axis, and it is showing a negative relationship between the price and the quantity demanded. And you can see the regression line. This is all because of the command I used. So when you are using it for your own, you're going to use a different variable in place of the Q and the P, which the question would have asked you to do. Then you can add the fitted line, which is a red line here. You can add a fitted line. Okay, and then you can, it's just a matter of copying this command, but understanding what you're doing. Okay? I have used color blue and color red for this. You can change the colors to show that you understand. Okay. And that is a simple regression that the question was asking you to do. But that was not all. It says use it to create a red scatter plot of TR and blah, blah, with a blue fitted line. So you can see the fitted line should rather be blue. The fitted line should be blue. But if you look at mine, the fitted line was not blue. Okay. So I need to swap them. I have to make the fitted line blue and then the scatter plot to be red. Okay. So you can see I've swapped them now, just as the question was asking. The scatter plot is red now, the fitted line is blue. Okay. This is observational learning. You don't have to just listen, you have to watch what is happening. You have to focus. You have to focus. All right. The next thing to do is, let's go to the question. Okay. The question says, and this now we are going deep. Okay. Specify a regression model for the entire data. ISA taught you how to specify a regression model. But you can't specify a regression model unless you have all the variables in your mind or in the Excel. One way to specify the regression model is go to the Excel data set and look at the names that was used for each one of the models. Another way of doing it is by using the entire correlation matrix. Another way of doing it is by, and this is important because if you don't take it, you won't get it. Another way of doing it is by doing the regression first in R and then proceeding to do the rest. So let me first use the Excel. Okay. This is the Excel. Specifying the regression model is by using the head columns. The head columns. How do you do that? One way you can specify the regression model is to make sense of the information that you have been given. The first value is Q. So the regression model is giving us Q equal to beta naught plus beta 1. Then you write the name of the first independent variable as it is. Guys, what is the name of the first independent variable as it is?
Look.
The name of the first independent variable is P. Then you do plus beta 2. The second one is C. Plus, just as it is here, beta 3. The third one is what? M. Plus beta 4. The next one is what? Log urban. And that one, the way you write it is this. You write it, let me write it here. Okay. So you do plus beta 4, and this is carefully done. Lock urban, that's how you do it. And you don't do the other one because the other one is a reference category. Then you do plus beta 5. And when you look at the occupation, there were 3 of them. So you have to do for 2 of them. So you do OC teaching. You've done all of this. I'm just doing. Then you do beta 6, OC. The next one after teaching is, let's say, trading. Just make sure that 1 is the reference category. You know, and then you go to religion. So you leave the fishing. You don't do the fishing because it's a reference category. Okay. Then you go to religion. You can do religion, beta 7, real Christians, and then beta 8, real Muslims, and then leave the Buddhist. So the Buddhist becomes a reference category. That is how you do it. That is how when you watch one of my videos, you see all of these things. And because you are specifying a regression model, don't finish without adding plus UI, which is an error term. Okay, plus UI, which is an error term. That's how you specify the entire regression model. Okay, using the data set. Another way you can do this, okay, and let me take you back here to the question. Another way you can do this is to do the M first. Run the multiple regression, dummy regression data set, do the M, question M, before you come to the L. That is one way. So you are running the thing, and then the results will guide you to be able to do the rest. Multiple regression model. Everything, multiple regression model. How do you do that? Well, it's a very, 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 very beautiful and a simple thing. So what I'm going to do now is I'm going to show you how you can do the multiple regression model in a simply beautiful way. Okay, so you use this command. I'm just going to show you in RR. I mean, you have the rest in the video, so you can check the rest in the video. I'm going to show you now. Okay. So in R, let's give it some instruction and call it multiple regression. Multiple regression. Multiple regression. And then I want to just dump the results here. Gene multi into equal to LM kill, then all the independent variables, P, C, M, block, OC, religion, data. Then you do summary, then the name of the results. Okay. I'm just running a simple OLS regression. But you bring all the independent variables. I'm calling it gene multi, and I'm summarizing the result. Look down there. This is the results down there, down there, down there in the console, down there in the console. Guys, this is the results. The whole of the results is what you see here. In our exams, I will give you all of these results. For your assignment, I'm allowing you to do things using the Excel. But in the exams, I will now do the whole thing in the Excel and give you this whole result and ask you several questions based on that. By the way, one advantage of this result, which is why I said you should do this first before you go and do the L question, specify the regression model. You can see all the independent variables on the column on the left. Okay, look on the left. Look on the left. All the independent variables are shown there. All of them. All of them. So if you check carefully on the far left, the names of the independent variables that you have to use, all of them are shown there. Remember, I mentioned location, urban. Okay. I mentioned occupation, teaching. You just pick them the way it is and add a beta 1, beta 2, beta 3, beta 4. You pick them from here. then you get them. So when you run the regression first, it will help you to be able to formulate the entire regression model by picking them just as it's been written there and adding the betas in front of them, just as I did. All right, but this is how you run the entire regression model, which was the question that was asked of you in M. In M, run a multiple dummy regression for the whole data set. Then you are to write the estimator regression line. Now this question, estimator regression line, is not difficult. And I know Isa went through that with you. That one, all you do is look at the results. Look at the results. Look at the results. Okay. Look at the results. So in this case, the results that you have will guide you. So in this very example, look at the results. The results that you're having here, the most important one is the estimate. The estimate are the coefficients. So all you got to do is to use the numbers of the coefficients. That's all you're going to do. You're going to use the numbers here for the coefficient. And you now use that to write the estimated equation, which he did. So in this case, the estimated equation becomes something like, okay, if you have usually mastered this, Q equal to, instead of bringing the beta, you bring the coefficient. The first coefficient is 280. So you bring 280.27. Okay, that's the intercept. Then you bring minus, then the second value, okay, 3.19, 3.16. But that is for P, so you attach P to it. Then minus, okay, 0.11. Okay, I'm just connecting it to two decimal places. Then you attach C to it. You are not specifying the regression model. You are writing the estimated regression equation. That's what you're doing. The estimated regression equation includes numbers and letters. Numbers and letters. Guys, if somebody is not really ready, the person should note that this is a compulsory question in the exams. That is why I'm taking my time to go through it fully. Okay. That is why I'm taking my time. So it's important you pay attention, master it, so that you know. The next one is to pick the next value, which is negative 0.9998. And that is for M, attach them. So you keep going, and then when you get to the religion Muslim, you pick the negative 23.01. And then you write real Muslims, just as it is there, real Muslims. Okay. And then you don't bring any error term because this is an estimated regression equation. Okay. Estimated regression equation, no error term. That is how you handle the estimated regression equation question. Very good. Now let's go to the next question to see what it says. Question O, where is our reader? Our reader, are you here?
I'm here.
Question O.
Question O, is the regression model reliable?
Good, I think this one, last time Isa answered it. Now, all of the questions that you're going to see from O to the end, you are going to use the regression results that you got. Is a regression model reliable? To do that, you use a multiple R squared down there to answer that. Who can tell us when it is reliable? Let me see what you learned well. Who can tell us when the regression model is reliable? Another way of saying that is reliable is regression model well fit? Is the regression model well fit? And that is another way. Yes, you can tell us.
Yeah, it is when the intercepts have significant values, p-values.
Okay, it's not about the intercept here. It's about what I've highlighted blue. The multiple.
Yeah, the F statistics.
No, that is not about. I'm just looking at the fitness of the regression model. I'm not looking at the significance of the coefficient.
Like it's about the R square value.
Yes, and I'm saying, how would you know How will the R square value help you to know that the regression model is well fit? That's my question. What will you see about that R square value that will help you?
It measures how much variability is accounted for by the in the variable we are predicting from the factors. So the higher it is, the more closer it is towards 1, then the fitter it is.
So is that when the R square is greater than 50%, then the regression model is well fit. Put that down if you didn't know. When the R square is greater than 50%, okay, my rule of thumb is when the R square is greater than 50%, then the regression model is well fit. Then it means it's reliable. Now the R square is the coefficient of determination. The R square, it tells you by how much the dependent variable changes if all the independent variables, you know, are changed. You know, in other words, it tells you the variation in the dependent variable when the entire regression line is changed. The R square, or the coefficient of determination, it tells you, okay, the total variability in the quantity demanded of gen, in our case. When the total variation, okay, it tells you the changes in the total variation as a result of the changes in all the independent variables. So when all of the independent variables are actually varying, okay, the behavior of the dependent variable, the percentage behavior, the proportionate behavior of the dependent variable, okay, will be given by the R square. So if the R square is 99%, like we have in our case here, 0.998, which is approximately 99%, corrected to decimal place. What it means is that 99% of the variation in the dependent variable has been explained by all the independent variables. So in practical terms, what it means is that 99% of the variability in the quantity demanded of gene betas, that 99% of the variability can be fully explained by the entire regression line or by all the independent variables. So the R square measures the reliability of the regression of the data. Okay, it measures the fitness of the data. So if the R square is bigger than 50%, then we know that the data is well fit. And we also know that the entire regression is reliable. Okay, so that you always use the R square to do that. Okay, that was a question that was asked there. That was a question that was asked there. The next question is question P. Can you ask question P?
Which of the coefficients are significant? Justify.
Chief of Staff, we have now come to your question you're asking. This is talking about the partial significance. Which of the coefficients, by the way, note that another name for the coefficient is the estimate. So you might not see coefficient in the regression results, but you see what? Estimate. Estimate. Okay. So he's asking you that which of the regression estimates are significant. So the estimates are here. How do you know whether any of them is significant or is not significant? You check the p-value. You check the p-value. You check the p-value. I can guarantee you somebody has been here writing everything I'm saying, recording in the mind and on the paper, everything, not relying on network, not relying on recording, not relying on anything. The person is soaking everything in. The person might not fully understand though, but the person is still writing, he's writing, he's writing, he's writing. And the more you write and you look at it with your eye, information is sent by the neuroplasticity of your brain. Your entire cerebellum and your cerebral cortex are enhanced by 49 notches. And so your entire being processes the information. You become a learner, not for an exam, okay, but for life. And so somebody is doing that. Another person too is also somewhere doing that. Okay. So please follow and focus. Follow and focus. So you use the p-value, which is on the right-hand side, to determine whether any of the coefficients is significant. How do you do that? Check the p-value. Whenever the p-value is less than or equal to 5%, okay, that is it. When the p-value, okay, is less than or equal to 5%, that is 0.05, then that coefficient is significant statistically. Then the coefficient is significant. Then the estimate, that estimate is significant. So when you look at each one of them, you will note, looking at the p-value, and I've told you how to interpret the p-value with the E and all of that. Looking at the intercept, let's just guess with the intercept. Is the intercept significant? Yes. Because when you look at it, there are 8 zeros before the 2. There are 8 zeros before the 2. So the intercept is significant. Looking at the price, look at the value of the price. Is it significant or is it not significant? Is it significant or is it not significant?
It's significant.
Why? Why do you say significant?
Because it's less than 5%.
It's not less than 5%.
It's just about 5% if we leave it at 2 decimal places.
Now you have spoken, and that's a smart answer. So I like that answer, okay? Because the rule is that if it is equal to, so it's equal to 5%. But based on the fact that we are leaving it at 2 decimals, that's important. 2 decimals, it is significant. Okay. If you understand it that way, understand. Then if you answer it but you don't get it. Okay, is the C significant or is it not significant?
Significant.
Okay. M, is it significant or is it not significant?
No,
Yes.
insignificant.
Good. What about location urban?
Not significant.
Good. What about occupation teaching?
Significant.
What about occupation trading?
Insignificant.
It is significant. That value is 0. What about religion Christian?
Significant.
It's significant. What about religion Muslim?
Significant.
Significant. So,
So why is trading significant? Because it's 1.08.
okay, so gentlemen, can you explain it to her? She wasn't here.
Yes, because of the exponent, it means there is 0.0000116. You have 5 zeros in front before the 16.
And yeah, what confused you was that value, isn't it? E minus 09. That's what confused you, isn't it?
Yes, sir.
That means that there are 9 zeros before the 1.08. There are 9 zeros before the 108. So
Okay.
this is that there are 0.0000000. So 9 zeros before the 108.
Okay. Then in that case, it's significant.
Yeah, because it means that it's 0. You get it? So that is how you determine individual significance of each one of them. Now let's go to the joint significance, all of them. This is individual. What about all of them? Read question, kill.
So you haven't shown the question.
They will come.
Are the coefficients jointly significant justified?
So that statement jointly means not partially. The first one we looked at individually, how they are significant, individually. But this one is asking you, put together jointly, are they significant? And there's a way you can justify it, okay? One way you can justify this is by using the F test. And the F test is at the bottom of your entire regression result. So when you look at the entire regression result, the last thing at the bottom is the F test. And your focus is by using the p-value, okay? That is your focus, the p-value, okay? Now, this p-value for the F test, if you look at it carefully, what value is that? Now that you understand what the E minus 1/6 means, what value approximately is that? What value is the 2.2 E minus, okay, with an exponent of 16?
0.
0. Okay, so because it's 0, the rule still stands. Whenever the p-value is less than 5%, it means that the coefficients are jointly significant. The key word is jointly. 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 All right. So that question, are the coefficients jointly significant? We say yes. Yes, because the p-value is 0, which is less than 5%. That's it. That one is very simple. So you should be able to make sense once you've gotten the results. Okay. The next one is interpretation of the results. Interpretation of the results. How do you interpret each one of them? I'm going to interpret one of them, which is categorical. I'm also going to interpret one of them, which is numerical. Okay. One of them, which is categorical, and then one of them, which is numerical. I'm going to interpret that. Okie dokie. So let's go to the results. I'm going to interpret this one called income. Income. Write it down. Write it down. Write it down. It will help you. Okay. Remember, we are talking about quantity demanded of gym bitters. And I'm interpreting the coefficient of income. If you look at the coefficient of income, it is negative 0.98. Negative 0.98. Okay, how do you interpret that? The way you interpret it is important. In exams, usually it is 7%. So it's very important you learn how to interpret them. Okay. How do you do that? For income, you will say that on average, because this is a mean. Okay, regression is all about mean. On average, given the price of gym bitters. So I'm saying given the P, given the price of gym bitters, the complement price of gym bitters, which is a C. Because I'm interpreting the M, which is the income of the people, I will not say given that one. So let me start. On average, given the price of gym bitters, the complement price of gym bitters, okay, the location of the shop. You see, I didn't say the location urban of the shop. I just said the location of the shop. The occupation of the people. So you can see that I combined the occupation, trading, and teaching together, and I just called it the occupation of the people. and the religion of the people. And the religion of the people. You see, once again, I didn't mention and the religion Christian and the religion Muslim of the people. No, because they are religion. So after you said that, so let me repeat. On average, given the price of gin, the complement price of gin, the location of the shop, the occupation and the religion of the people, a 1 unit increase, okay, a 1 unit increase in the income of the people. Now we are talking about the M. A 1 unit increase in the income of the people, which is the M, okay, will decrease. Why decrease? Because the number is negative. Will decrease the quantity demanded of gin bitters by 0.98 units. You see, I use the word units. I didn't say cedis. I didn't say dollars. I didn't say profit. I didn't say percentage. I didn't use any specific unit of measurement. The only thing I used was units.
Sir, can I answer a question, please? Okay, so in exam, can you say that on average, holding other factors constant?
No.
Holding other factors constant.
All of those other factors. You are supposed to mention all of those other factors for this exercise for you to prove that you know what you're saying. You have to show your understanding. When you have mastered it and one day you are writing a paper, you can say that holding the other explanatory variables fixed. But for this exam, you have to mention all. That's why I specifically went through the example. Okay, so this is how you interpret a dynamic variable. Why dynamic? Because price is changing. It's not constant. It's not a dummy. It's rising. That's why you said a 1 unit increase in the income. So income is increasing. So what it means is that if income increases by a unit, how would the dependent variable, in this case, the quantity demanded, change? It will also fall. Why fall? Because there's a minus in front of the 0.98. It will fall. But that is not the same way you interpret a dummy variable. So I'm going to show you how you interpret one of the dummy variables. Which are the dummy variables? There are quite a number of them. You have location, urban. You have occupation, teaching. You have occupation, trading. You have occupation, trading. You have religion, Christian. You have religion, Muslim. Okay. What I'm going to do is I'm going to just interpret one of them. The last one, religion, Muslim. Now, anytime you are interpreting the dummy variables, okay, and you will know that this is a dummy variable because the storyline will let you know. Anytime you are interpreting the dummy variables, you must know in your mind the reference category. So if you look in the results, under location, urban was brought in there. Okay? But you know that there were 2 types of location. So you know that the reference category must be which one? You know that the reference category must be which one?
Rural.
Thank you. Now, in the occupation, you had occupation teaching, occupation trading. So it means that you should know that the reference category must be which one?
Fishing. Fishing.
Good. In religion, you know that the religion, we have Christians, we have Muslims, and so the reference category must be which one?
Okay.
Okay. So that is how you learn. And so I'm now going to interpret religion Muslim, but I must have the reference category in my head. So this is how you start.
Sir, Sir, please, what is a dummy, this thing that you said? I want to understand that thing, dummy.
Dummy variable is a variable that is not changing, it's constant. So if price increases, you will not change your religion from Muslim to Islam, it's static. So it's a variable that is static, it's not changing, at least within a year, that variable is not changing. Location, you will not easily be changing your location every week. Neither will you be changing your occupation. So dummy variables are variables that are static, that are not dynamic, that are not changing. And we are going to interpret them. So if they are not changing, how do they affect the variables that are changing? You get it?
Yes, sir, thank you.
All right, so religion Muslim. So this is how we are going to start. On average, given the price of Jane, the complement price of Jane, this time I'm mentioning income because income is not what I'm interpreting. The income of the people, the location of the shop, the occupation of the people. See, I didn't talk about religion of the people because I'm interpreting one of them. And because I'm interpreting one of the religions, I can't say giving the religion as well. The word giving here means fixed. The word giving, it means fixed, being held constant. So you start by saying that on average, given the price of Jane, the complement price of Jane, okay, the income of the people, location of the shop, occupation of the people, quantity demanded of gin bitters is expected to be, there's a word, okay, or is predicted to be. It's predicted to be what? It's predicted to be, then you now go to the value of the thing you are interpreting. It's predicted to be 23.01 units less if the people are Muslims than Buddhists. If the people are Muslims than Buddhists. Why Buddhists? Because Buddhist is a reference category. So anytime we mention Muslims, we are talking about Muslims in relation to Buddhists. In relation to Buddhists. So quantity demanded of gin bitters is predicted or is expected to be 23.01 units. No percentages here, no dollar here, no city here. Okay. Units less. Why less? Less because the 23 has negative in front of it. If it had positive, we would have said 23 units more. Okay. If the people are Muslims, because we are interpreting Muslims, then you compare it with a reference category. Please note, we didn't say that quantity demanded will rise by, there was no rise or fall here. Because religion does not rise and fall. The person's religion doesn't increase or decrease. That is how you interpret it. Knowledge is not power. Applied knowledge is power. How you interpret these things will help you.
Sir, please, can you take the interpretation again?
On average, given the price and the complement price of gin, income of the people, location and occupation, location of the shop and the occupation of the people, quantity demanded is expected to be 23.01 units less if the people are Muslims than Buddhists. Either people are Muslims and good. Go and check past questions. You see that this is a lot of marks. The ability to interpret dynamic variables is not the same as the way you interpret, categorical dynamic variables. So that is how you do it. Go and look at the rest and then master your hands on how to interpret them. Now, this question is, ask the question, I want to show you something.
And what? In which type of assembly are the property tax rates highest? Justify.
All right, so that word assembly, it is one of the dummy variables. So it's actually in which one of them are the property tax rate highest? I could have asked that same question in your R here. I could have asked the question that in which of the occupations here, okay, in which of the occupations here is the quantity demanded of gin stronger, okay, or paramount? In which of the occupation here is the quantity demanded of gin being used the most? What would you have said? Which of the occupation would you say quantity demanded is being used the most? Well, all you have to do is to look at the coefficient of the two religions that are there. One is -19, the other is -46. So the one with the highest absolute value, that is the one. That is the one. That is the one, and that is the one that will be the highest in this example. So you should always look for some few tricky questions like that. All right. Now, let's go to, we have two more, but I will not talk about these two today. Okay. The last but two things you should master, which we'll look at next time, is multicollinearity. Okay. You come to understand multicollinearity and then prediction. Multicollinearity and prediction. That is what is left. Okay, next time when we meet, so that you can appreciate and understand it. So go through all of this, and then when we meet next time, you have questions. When you don't go through it before we meet, you struggle. Okay, but go through it, master what I've just said, and you will get it. Okay, but it's not just about getting the videos and watching again. You can get the videos, but somebody will still not pay attention and will still not understand. It's very important to understand it all. All right, ladies and gentlemen, that brings us to the end of the